Hello everyone, I'm Dr. Mamta Gautam from ABES Engineering College, Ghaziabad. In the previous lecture, we discussed about the water softening process part 1, zeolite process. This is the unit 4, engineering chemistry, water technology. Now, today we will discuss about the water softening process part 2, that is ion exchange process. In this lecture, we will cover introduction of this process, types of ion exchange resins, process, regeneration, advantages and disadvantages. Firstly, I'm going to discuss ion exchange process. This process, it is also called as deionized demineralization process. What is ion exchange process? In this process, both cation and anions will be removed from the hard water. For this, we are using ion exchange resins. What are resins? Resins are insoluble, cross-linked, high molecular weight organic polymer with microporous structure and functional group attached to the chains which are responsible for ion exchange properties. This is the ion exchange resin. How many types of ion exchange resins? Ion exchange resins are of two types. Number one is cation exchange resin and second is anion exchange resin. Firstly, I'm going to discuss cation exchange resin and it is denoted by Rh positive. R is the insoluble polymer matrix and H positive is the acidic functional group. It means cation exchange resins contains the acidic functional group. It is a copolymer of styrene divinyl benzene. After sulfonation or carboxylation, it will become capable of exchanging their H ion with the cation of hard water. Acidic functional group like carboxylic acid group and sulfonic acid group. This is the acidic functional group that is contained by cation exchange resin. Cation of hard water, calcium ion or magnesium ion. Both are the removed by cation exchange resin. And second ion exchange resin is anion exchange resin and it is denoted by ROH negative. Anion exchange resins contains basic functional group. They are styrene divinyl benzene or amine formaldehyde. It means it is a copolymer. Copolymer means more than one monomers are used. This monomer, after treatment with NaOH, become capable of exchanging their OH ion with the anion of hard water. Anion of hard waters are chloride ion or sulfate ion. Anion exchange resins contain basic functional group, amino group, quaternary ammonium group. And these anions are removed by anion exchange resins. This is the structure of cation exchange resin and anion exchange resin. Cation exchange resin means it contains the acidic functional group Anion exchange resin means contains the basic functional group. And this H ion is replaced by a cation of hard water. And this OH ion is replaced by an ion of hard water. Cation of hard water, what? Calcium or magnesium, and anions, chloride ion and sulfate ion. You can see here acidic functional group H, basic functional group OH. And this is the assembly for the purification of demineralization of water. You can see here we have two tanks. One tank is cation exchanger bed and second is anion exchanger bed. Firstly, when hard water is passed through this inlet and coming contact with cation exchanger bed, all the cations are taken up by this resin and release the equivalent amount of H positive from resin to this water. It means cation exchanges taken up all the cations. Cations means calcium or magnesium. After this tank, water is passed through the anion exchanger bed. Anion exchanger bed taken up all the anions, chloride ion or sulfate ions. All the anions, chloride, sulfate ions are taken up by this resin. An equivalent amount of OH ion is released to this tank. This tank means cation exchange release the H ion and anion exchange tank release the OH ion. After this, cation exchanger bed and anion exchanger bed gets completely exhausted. Exhausted means cation and anion exchanges are used continuously and they lose their ion exchanging capacity and become exhausted. These are the reactions for the cation exchange resins and anion exchange resin. First, I'm going to discuss the cation exchange resin. Cation exchange resin is denoted by Rh positive and react with hardness causing cations. These are calcium ion or magnesium ions. All the cations are taken up by this resin and release the equivalent amount of H ion to tank or to you can say to water, and it will form the R2Ca++ or you can say R2Mg++ and release the equivalent amount of H positive from resin to this tank. And second reaction is anion exchange resin. After cation exchange tank, water is passed through the anion exchange tank. All the anions like chloride ion, sulfate ions are taken up by the resin, an equivalent amount of OH ion is released from this tank to water. Anion exchange resin are OH negative, react with anion of hard water, that is chloride ion, and taken up by the resin in the form of RCl negative and release the equivalent amount of OH ion. Similarly, as ROH negative react with sulfate ion and taken up by the resin R2SO4 minus minus and release the equivalent amount of OH ion. Chloride ion and sulfate ion both are the hardness causing anion. Calcium ion and magnesium ion both are the hardness causing cations. Cation exchange resin taken up the calcium or magnesium, and anion exchange resins taken up the chloride ion and sulfate ion. As I told you before, let's start the regeneration. As I told you before, as the cation and anion exchanges are used continuously, they lose their ion exchanging capacity and become exhausted. Now regenerate the cation exchange tank and anion exchange tank. Cation exchange resins are regenerated with the help of dilute HCl, and anion exchange resins are regenerated with the help of dilute NaOH. You can see here cation exchange resin H positive and anion exchange resin OH negative. H positive plus OH negative combine to form H2. This water is free from all the cations as well as anion from the hard water. And it is called as deionized or demineralized water. Water becomes free from all anions and all the cations. That is called as deionized or demineralized water, just like distilled water. Regeneration. R2 Ca++, that is the exhausted cation exchange resin regenerated by dilute HCl and release the calcium or magnesium. R2 Mg++ plus HCl and regenerate the cation exchange resin and release the magnesium ion. Calcium or magnesium can be used for washing. cation exchange resin anion exchange resin. Exhausted anion exchange resin react with OH ion from NaOH and it will reclaimed or regenerated the anion exchange resin. Similarly as exhausted anion exchange resin react with dilute NaOH and again it will regenerate the ROH negative, that is the anion exchange resin, and release the SO4 minus minus. Regenerate cation exchange resin regenerated regenerated anion exchange resin. Now coming to the advantages of this process. This process can be used to soften highly acidic or alkaline water. And in this process, water is obtained residual hardness 2 ppm, and this water can be used in high boiler pressure. Disadvantages for this process: if water is turbid, resin's pores will be blocked and efficiency of the process is reduced. And this equipment and chemicals are very, very costly. If we use hot water, then resins will dissolve in it. These are the references. Thank you all.